ago with exactly the vision that you see start to play out today. That computer tools that allow you to do the kind of things we just saw before the break would enable a reorganization of time, because we can look at more issues earlier on and put the project on the right track. So what if what if buildings actually performed as designed? Or what if you could develop and analyze a structural design option for a large project in 3 seconds? Or do an energy and daylighting analysis for a city block size building in 3 minutes? Or you actually knew what is the most effective management intervention or thing to pay attention to this week, and why that is. Or everyone on the project used the same playbook. Could you do something with any of these? If yes, then we should maybe talk. We have done all of these. You might think this is absolutely crazy, but we have done them. So, also in reference to what we just saw, Francis Ford Coppola, I heard him in an interview on NPR. He said, the secret, he was asked, what is the secret to a good movie? And he said, it's very simple. Make sure everybody is working on the same movie. And I think we've seen quite a bit reference to that. But I think that's certainly one thing that I see a DProfiler doing, is making it much more likely that everybody's doing the same movie. But I think it's doing more than that. And I think we're also into that. It's not only ensuring that you're working on the same movie or the same project, you can also look at many more options, and you look at them from many more perspectives early on. So you are less likely to fall into the trap of having to sub-optimize the majority of the project because a few people had some idea that seemed like a good idea at the beginning of the project, which is a more common way how I see projects being done. And since design is a very inexact science, the only way we can get to good solutions, the best way we know to get to good solutions, is by looking at many, many options from many perspectives. And so we should start, in my mind, a project that is trying to do the right thing, because the compromises will show up soon enough. So if we start with a compromise from the get-go, then we certainly will likely to actually, most likely will end up with a very bad compromise. If we start with what's the right thing, we have a chance of ending up with a good compromise. And I think the right thing is a project that really understands, where the team understands the trade-offs between design, construction, cost, and duration, value from the facility, and then operating and other life cycle cost and duration. And exploring that is a difficult thing. Not any one of us can possibly do it in our heads. I think that's where the kinds of tools that we saw presented help tremendously, and the kind of methods we want to contribute to. So, to start with one of my favorite quotes that I often share with my students, because they haven't usually come through the line of the workforce. I like this quote by Napoleon, who said, "I've made all my generals out of mud." So then thinking about, okay, what does this mean for somebody like my son, who is 15, and I don't know if he's going to go into this profession, but some of his colleagues will. What kind of mud does he need to be exposed to so he might have a shot at becoming a general? If we think about it, we can be tremendously proud in our industry for all of the buildings, all of the infrastructure we have put in place for the world to function and be productive. At the same time, though, we also see lots of too many detrimental impacts and too much waste in the process of doing so. So I think there's tremendous societal need for improvement and business need to improve. We can also be proud, for the opportunity we've given to people, but I'm not sure that this generation, how well, this generation will learn the 2D-based process. Actually, I'm convinced that they will not learn it, and at least at the time when companies need to hire the people who are currently 15, might be sooner, we have to have very different processes in place, because they will not learn these processes. They will rather work somewhere else than learn these processes. So I think from the need to, from the opportunity and need to attract young talent, I think maybe that alone warrants changing to some new processes and methods. And from the tool perspective, I think we have begun to move from, a practice that I've seen that you could summarize as something like Weikerswick, you can't always see what you get, to basically what you see is what you get. I think the successful companies that I work with, they provide that level of service to their company, to their clients. In the future, I think the tools we are seeing to emerge now and that we're working on will allow you to get what you model. And by model meaning performance model, not just visually model. Because, why can we do that? Because we are truly at an unprecedented time in the history of construction. Maybe you've heard this many times, but I think this is really the case because never ever before have we had tools, and that's where I do want to make a plug for the tools because they are terribly important. Never ever before have we had tools that combine the data that drive all of the business aspects and the visualization, which is what we need to be on the same page to make the same movie. Those were always separate. And today, we have tools that put the two together. And that is incredibly powerful. Now add to that the very recent emergence of the sensing, the cloud, and basically free computing. Essentially, the computing process is almost free. And I would say we have not begun to think about what the opportunity that creates for us in our industry. So how we work at CIFE is we focus on research and education, but in conjunction with practice. So it starts with practice to see for opportunities for improvement, which leads us to do research together with the companies we work with, always in the context of their projects, which then gives rise to new classes we teach, professionals and to Stanford students, which then enables new practice. And I think the faster we can go through the cycle, the more we can go through the cycle together, the better off all of us are in terms of creating the next practice. So we see virtual design and construction as an essential sort of concept, tool, mindset to get there, basically consisting of metrics or objectives supported by technology, called here BIM+, social process, which we call integrated concurrent engineering, and then reorganized process steps organization of the project. It really takes all of these parts together to make a project successful. You know that. But when we put it all together, supported by modern tools and management methods, we can be, I think, far more effective. So a couple of vignettes of what we're working on, but this is really just a few vignettes. We're always driven by our members. We want to understand how buildings function much better, so we can connect that knowledge back to the design stage and create, basically close the loop between what we imagined early in the project with how it actually turns out here. An example of energy performance, looking at predicted and observed performance, which doesn't match up very well, as you can see by the vastly different graphs. But also trying to connect the level where the value is created at the space, where the cost occurs at the system level, and where you can intervene at the component level. Doing case studies with our some of the companies we work with here. We did a case study of Adobe's energy efficiency practices over the last 10 years. They have a very successful practice in that respect on their headquarters in San Jose. The highest LEED EB score ever achieved, and Energy Star rating of 100. So how did they get there? What did it take? What lesson can we learn from that? So we try to learn from the best. We do quite a bit of work on the management side of the industry, connecting process and outcome metrics to decisions that the project teams can take. In this particular case, a collaboration with DPR, where we looked at the MEP coordination process, and out of sort of lots of projects where they have done MVP coordination with 3D models. They've distilled and lean management methods. They've distilled a 6-step process, which they say, okay, this seems to be best practice, as best as we can determine. And we are now, we did a sort of initial test and say, okay, projects that use this method, which they call IVL, for integrated virtual and lean coordination method. They wanted to understand, well, if projects actually follow this method, are we doing better? Is it even worth telling our project managers, hey, pay attention to this? Or should we just leave them to their own devices? And so we did just 4 case studies as a very first step to see if this is even feasible to do. In these 4 case studies, we found that when the IVL score is higher, meaning this method is used more, then there was less time by superintendents spent on field conflicts, actually quite dramatically less, about 5 times less. There was a higher degree of plumbing prefabrication, higher degree of mechanical prefabrication, fewer change orders, far fewer change orders, far fewer RFIs. And let's see, what is the other part here, the last one? And less rework, yes. So, but this is just 4 projects. We're now expanding the study to 150 projects. We'll be reporting shortly whether what's shown here plays out, or I suspect the richer story will emerge to this. We also connecting to other parts of the university, in this case the Department of Economics, where Mr. Bloom is working, who together with Van Renen, a guy at the London School of Economics, did a study where he looked, they wanted to find out for manufacturing enterprises what is the best predictor of their success. Is it the charisma of the CEO? Is it the average age of the people in the company? What is the best predictor of success? They found that good management practices are the best predictor of success of the company. Good management practice is basically defined by setting objectives, measuring to get them, measuring them, tracking them, following up on them, closing the loop. I mean, fairly theoretically straightforward stuff, not that we see it done all the time. So they measured thousands of companies and found a wide range of management practices from good to bad, and the ones on the good side had far greater likelihood of success. So now we're taking this framework and this approach of the construction industry, trying to see if we can measure similar kinds of effects and connect also what the project manager is doing every week to how happy the client is with the project. And do any of the things that the project managers are tracking every week have actually anything to do with whether the client thinks it's a good job or not. So by collecting enough data, we can do then statistical analysis and see if that seems to be the case. You might have wondered about the 3-second structural design. So we worked together with Arup on 3 of their projects and employed multidisciplinary optimization method from the aerospace that was developed in the aerospace industry, which basically allows you to stitch together the parametric modeling tools, CAD modeling tools, and analysis tool in a software environment, and you can then define the range of options you want to look at, and let the computer go look at these options and analyze them. By using parallel computing, which is essentially quite affordable even today, and certainly will be very affordable very soon, we can do a development of an option and an analysis for the structure of a soccer stadium roof, 65,000 seat stadium, in 3 seconds. So this allowed us to look at about 8,000 options instead of the design was 39 options, and come up with a design that was about 20% more effective from a material use perspective. And we're working with back technology to bring this kind of technology into your world. We're also on the education side working with our members, because they basically said, well, in 5 years, in 10 years, we see we need to work this way, but how are we going to do it? Because the majority of people that will get the projects done for us are already working for us today. And we have to somehow nudge them along to learn this different way of working. So we help our members in a week-long course navigate sort of the space of how to deploy integrated concurrent engineering, BIM, process production planning and control, and thinking about metrics over the course of the whole project. So that when you're at the very beginning of the project, this is from one of these classes that we did with Disney, Walt Disney Imagineering, so hence we call conceptual design blue sky, or pre-conceptual design blue sky. But so that when you are working in conceptual, or very early in the project, you're thinking about all the life cycle of the project. And then you're carrying what you learned here forward, and you're thinking about the rest, and so on. So you're still stepping through the project in the way we know, but you have much better information to build on, and you have much better foresight. But this requires a bit of guidance, we found, so that the right performance metrics can be set, and then the right tools can be picked out of the whole, the right errors can be picked out of the arsenal of errors that have the biggest effect. So that's another aspect we do at the center is on the education side with our members. So that here you see a project team that's going through this session. This is a UCSF Mission Day Hospital project team, where 32 participants from 11 companies spent a week with us to hash out how they're going to do the project and invented basically the playbook they're going to do together. Realizing together that when the architect thought he was finished with design wasn't really finished, it's just the next phase, and they really had to work more closely in terms of making it buildable and then documenting the buildable design, and then signing off together on this process to also to pick up on Peter's story at the very beginning. So, in a nutshell, as you might expect from somebody from Silicon Valley, we want to work with our members to do really great, important things. Because, again, as Napoleon says, glory is fleeting, but obscurity is forever. So thank you. I got all, so I want to be a little sensitive to that. Steve?
I have a question. When you look, you talked about attracting talent to the industry. One of the knocks that we get in the industry is, people don't have the experience level anymore, and the technology enables them to do a job they don't really have the experience to do. I wonder if you could elaborate maybe on what the flip side of that is, because sometimes the technology can accelerate that learning curve. If we pay attention, if we just give them a program and say, do this, and do this, they're not going to get it. But if they actually use that technology as a learning tool, I don't know if you might be able to touch on that.
So if I can share an anecdote of this, that illustrates this point. Technology is not a panacea, but it can certainly be a powerful enabler, just as you said. That's certainly what I've seen. So one of the people in the construction industry I respect the most is Greg Knudsen. He was the general superintendent for Mortensen on the Walt Disney Concert Hall, which still, for me, probably the most complex building I've ever seen and been on. Even beyond refinery work, etc. Just because of the extremely wide range of requirements and complexity of the spaces and how they were broken and so on. So he called me up a few months ago, and he said, he's up in Seattle now, and says, Malcolm, we can't quite get our structural engineers to work with us in a really effective way around building information models. So I said, what do you mean by that? And on the phone it was difficult to sort of sort this through. So I said, okay, why don't you fly down and I'll introduce you to my friend Greg, who is a structural engineer, he's a small structural engineering company. And because that's the best that I know. Greg is his name. And why don't you go and see what he does, and then visit down, and then you can tell me this is perfect, this is exactly what I have in mind, or this is way too much, or not even nearly enough. Then you have a shared reference point. So he did that. We all had dinner together, the two Gregs and me. And so I asked Greg, the contractor, I said, so what surprised you from the day? He said, the biggest surprise for me was that all the presentations made today in the structural engineering office were made by 3 young engineers who had been at the company at that time 11 months, 5 months, and 3 months. And he said, if all my staff, if you're models competitive, you might think, well, yeah, of course that's models. But he said, if all my staff had that level of construction experience in a construction company after 10 years of working with me, I would be really happy. And he said, it's because, A, you were there as a mentor, and Greg Luth, he has this construction structural combination experience, but it's because also the technology accelerated their learning because they had to make everything work out and had to fit everything together in the 3D model. Because he likes the 3D model, says, build this. I take the risk, dimensional, everything, I take the risk. I want you to build what I design. But it's surprise, not that many designers, it seems to me. I'm a structural engineer, so I'm a structural engineer by training, by education. And that's the tool I would want. Right? If I design it, that's what I want. Right? That's why I design it. So I'm really surprised that that's not prevalent attitude. But he definitely saw the accelerated learning, which was enabled by the technology, but also, of course, by him being there and mentoring.
It does take both.
It does take both. So, but I think that the companies where I've seen where they're able to bring people that love to work with the technology, with the new technology, together with those that really understand all the aspects of our work, that's where I've seen just unbelievable improvement in efficiency. But also, it's a lot more fun for everybody that's part of those projects. So that's also, I mean, that's the kind of scenarios where we want to be part of, that we want to educate people